All right, I chose a Wilson NFL football here for my solid of choice. You can see some of my sub-interval marks there. They're at 1 inch intervals. Started off with just some basic X and Y values that I just kind of copied and pasted from an Excel spreadsheet and put that in Desmos to help with the regression formula. Everything's in inches, so coming from the left to the right of the football or from the point to point would be my X values, and then from the midpoint, pretty much the seam here, any of the seams up to the peak, this distance here being my Y values. So plotting those in Desmos, using the regression tool to help me get a pretty ugly quadratic formula, but nonetheless it fit really well with the model. Setting my delta x to 1 for my interval size, utilizing the volume of a disk formula, where r, or the radius, was just going to be my y formula, my regression formula that Desmos helped us establish. Using the Riemann sums, I went with a right-hand Riemann sums, just using that summation notation and just kind of manually finding out each of those individual interval values and then writing them down, adding them up to a total of approximately 281 cubic inches for the volume. Moving on to integration, just kind of helping myself see what's actually going on, just knowing that basically just pi times r squared, which in this case is going to be our height, or our y, our function value, times thickness, which is dx, that we said was set to 1. Up here, our delta x. Little brutal working with that nasty quadratic, but just slow and steady working with it, and then came out to a very similar figure of about 281 cubic inches as well. And then for the physical method, I was a little stumped, and so I just resorted to a water displacement method. I just had a 5-gallon bucket filled to the brim with water, had that sitting in a larger plastic tote, dropped the football down just below the surface, and was able to measure the water that was pushed out of the 5-gallon bucket into the larger tote, which came out to approximately 3,600 milliliters, recognizing that milliliters are equal to 1 cubic centimeter. Doing a little conversion from cubic centimeters to cubic inches led me to about 220 cubic inches. Compare that with, once again, our Riemann sums and our integration method, which were approximately 281. So everything was fairly close. Some possible errors could have been the football not being fully deflated. That might have created a little bit lower value on this volume, as well as just human error, me kind of approximating the water, not using a precise graduated cylinder. All right, thank you guys.